Okay, here we have a pretty simple question. Water is flowing through a channel at 20 liters per second. The channel is 2 meters wide. The water is flowing at a mean velocity of 0.1 meters per second. What must the flow depth be? So I'm going to start by doing what I always say you should do, and that is identify what it is we're looking for. So we're going to highlight, make it really clear that we want to find flow depth. So flow depth, it's a depth, it's going to be something, some sort of distance. So we're looking at units, something like meters. We'll call that H. So the second step that I always advise is to then identify exactly what you're dealing with. So we want to consider the drawing. We want to consider bullet pointing all the information and highlighting it. So we're told that it's a channel. So I'm going to assume it's rectangular. The question states that it's 2 meters wide and we're looking for a depth. It's not a complicated question. It's probably going to be something simple. So I'm going to assume a rectangular channel. So some sort of cross section as such. There's our flow surface, something like that. Okay. So we're given the width and we're looking for the depth, H. So we have from that, we can assume that there'll be a cross-sectional area, and we're told we have the flow rate and the velocity. We're now going to just bullet point out exactly what those things are. So we solve the flow rate, 20 liters per second, the velocity, 0.1 meters per second, and the width is equal to 2 meters. Just to make this simple now, convert everything into SI units, velocity and width already there. We're just going to change this charge to meters cubed per second by dividing by 1,000. There are 1,000 liters within 1 meter cubed. So we're going to divide by 1,000 and we're going to get 0.02 meters cubed per second. Okay, so first two steps. 1, identify what we're looking for. 2, identify what it is we're starting with. Now we need to work backwards for our third step, from what we're looking for to what we started with. Working backwards is going to be a great way to problem solve. Okay, so we need to be thinking, what kind of equations will give me flow depth considering what I have in front of me? The first one, the most obvious one, is going to be that your cross-sectional area is equal to your depth times your width. By rearranging this equation, we see that depth is equal to area over width. Now we look to see, what do we have for each of those points? Do we have area? No. Do we have width? Yes. So to be able to use this equation, we're going to have to find out what area is, which is the first step on the ladder. The next step is going to be working out what area is. So obviously we're not going to work out area using the geometry. We're going to need something else. So from that, we can use our equation Q equals UA, as we have discharge and velocity. So U is the average or bulk velocity within the channel. A is the cross-sectional area. We can rearrange this to give us Q over U. Putting the numbers in, we get 0.02 over 0.1, and that will give us 0.2 meters squared. You can see here that we now have the area. As we have the area and the width, we can now use our first equation to find H. That means that your depth is going to be equal to 0.2 over the width, which is 2. Put that together and we get a depth of 0.1 meters. And that's how you solve it.